We're looking at transformations in section 2.7. We already talked about translations, also known as shifts, and now we want to talk about stretch or compression. So we have a little example here to help us understand it. The question says, what happens to the basic function of y equals absolute value of x if we multiply it by 2? How does the graph of 2 times the absolute value of x compare with the graph of y equals absolute value of x? And so we can make a table and plot points to figure that out. In order to save a little time, I've already completed the table and the graph for the basic function. And so then we can just come back and work on the new function. 2 times the absolute value of x. Probably you can see that if you already have the absolute value of x here is 4, then 2 times that would make 8. And if you wanted to, you could show a little extra work. You could actually show the substitution and then simplify and get 8. The rest of the y values would be 4, 0, 4, and 8. And then you can plot those points. And we can use a ruler to draw the new graph. Okay, we have the graph. How would we describe this transformation in words? Well, we could say that this is a vertical stretch. If we look in the vertical direction, the points on the original graph got stretched away from the x-axis, got pulled away from the x-axis. The point that was on the x-axis there at the origin stayed fixed, but all the points above the x-axis got pulled further away, and if there were points below the x-axis, they would get pulled further away from the x-axis as well. They would get pulled down the same way the points above the x-axis are pulled up. So we'll see that again in a few minutes. For now, what we'd like to do is we'd like to say that this is a vertical stretch and we could say a factor of 2. The most important thing is to call it a vertical stretch. Sometimes students look at this and they see a horizontal compression. And that's a reasonable thing. If you think about this in the horizontal direction, the points on the blue graph are getting squeezed or compressed toward the y-axis, toward the middle. On either side. However, if we look at the function that we're talking about, this 2 times absolute value of x, we see that the 2 is outside the absolute value. And so we'd really like to think about that as a vertical change, as a vertical transformation. That was one of the things that we emphasized in the previous video. So outside the basic function should be a vertical change. So let's think about it as a vertical change, and then we decide it's a vertical stretch. It's true that in this case it's equivalent to a horizontal compression, but that will definitely not always be the case. Okay, so let's go on. Let's see what happens now if we multiply by a half instead of by 2. We're still going to multiply outside the basic function, and so we should expect another vertical transformation. So I've already made the table and the graph for the basic function. If we come through for the new function, in the table we'll get 2, 1, 0, 1, and 2 for the y values. If I went kind of fast through those. You might pause and make sure you agree that those values are correct. Make sure you understand where they came from. And then we can just go ahead and plot the points and draw the graph. Now, if we look at this transformation in the vertical direction, we see that the points on the blue graph, on the basic function, are getting squeezed down, are getting pushed down toward the x-axis. So they're getting compressed toward that x-axis. And of course, the point that's on the x-axis, again, doesn't change. Points that are above the x-axis get pushed down toward the x-axis. So we're going to call this a vertical compression. And again, we could put the factor in there. We could say by a factor of 1/2. Okay, and so we have been talking about stretches and compressions, and we focused on the vertical direction in talking about stretches and compressions. Let's summarize what we learned. So if we have y equals a times f of x, that's a multiplication, and it's outside the basic function. This is a multiplication, and it's outside the basic function. And so you know already that outside the basic function means that the transformation is vertical, and multiplication, we just learned, produces a stretch or a compression. And so the factor that we're multiplying by here is a, and so if a is greater than 1, then we're going to be stretching the graph. We'll have a vertical stretch. And if a is between 0 and 1, then we'll have a vertical compression. Okay, so let's practice just a little bit. I've got a problem here that says use transformations to graph 1/2 times x cubed. So do you know what the basic function is? It should be y equals x cubed, and then the transformation is the multiplication by 1/2. It's outside the basic function, right? Because the cubing happens before the multiplication by 1/2. So it's outside, so it's vertical. And since the factor is less than 1, it would be a compression. And so now we can go ahead and sketch that transformation. So it takes just a little bit of practice to make a nice graph here. If your graph doesn't come out great the first time, just try to draw it again. You know, the key here is to sketch y equals x cubed and leave room for the vertical compression. Remember, the points that are above the x-axis are going to be pushed down toward the x-axis. So out to the right, the graph is going to be flattened out, something like that. And to the left, the points are below the vertical axis, below the x-axis, so they'll be pushed up toward the x-axis. So something like that. That's not the greatest graph I ever drew, but it's pretty good. So we can label that f of x is equal to 1/2 x cubed. Remember, we just want the basic shape of the graph, and we want it in comparison to the basic function.